is ECS. Okay. So I'm going to be deploy the full stack application. The full stack is the front end, back end, database configurations, including. Okay. So the application is Node.js application. So this application already, most of the team is familiar. Already we done so many projects, AWS, manual process, with help of Kubernetes. We already done this project. So the same project, if on ECS, so how the project will work. Okay. So a very important thing, okay. Okay, ECS, Elastic Container Service. Okay. So first, what we can understand from this workshop, and prerequisites for this workshop is AWS knowledge is required to understand this workshop. The person is having AWS knowledge already. Okay, AWS and DevOps knowledge, so they can understand easily. Okay. So this is mandatory to understand this workshop. If you are a fresher, you don't know what is cloud and DevOps, it's too difficult to understand this concept. Okay. Yeah. So even though if you are a fresher, try to understand what kind of concepts are there in the DevOps only. Instead of focusing on this concept, how the life cycle will work, DevOps life cycle will work. What is, full stack, configurations, how to do that, front end to back end and database. And very important thing, this one more prerequisite is there, DevOps here inside, Terraform knowledge is mandatory to understand this workshop. So here, the skill set, the workshop skill set, if you can see, ECS, Fargate, Terraform, hot cake in the market now. Fargate, ECS, Terraform is a hot cake in the market. So I'm adding these 3 tools for the one project, that to full stack. Okay, full stack project means if you we don't know anything, can you please focus what is the process and all? Okay, what is ECS at least? Okay, so if you don't know anything, no, in your interview, they won't expect anything from you as a fresher. They may ask what is ECS, right or not? They won't ask you to develop a one project on ECS. You don't have that much of experience. But freshers, you can concentrate here. Okay, I know what is ECS. In interview also, they will expect from you what is ECS, what is the difference between ECS and EKS, Fargate, EC2. This kind of questions you will get. Okay, so that you will also benefit, even the fresher also. Okay. Okay. So I will try to explain now from the scratch. First, before ECS, before start to ECS. So ECS is a AWS tool. Elastic Container Service is a AWS native tool. Okay. Yeah. Let me write. You will get a clarity. AWS own tool this is. ECS is a AWS tool. Okay. And what is ECS? So most of the people say containerization tool. Yes, correct only. Containerization plus orchestration tool also. The most important is orchestration. Guess what is the meaning orchestrate? He is the best orchestrator. Means what? Manage a team as a good level. Manage the multiple tasks is a good orchestrator, right or not? So here, then ECS is a good orchestrator. And ECS is a good orchestrator means what? ECS is managing the background, the things at very perfect level. Okay. So in this case, what is orchestration first? Why ECS need to be orchestrated here? Why we need a orchestration tool help in the DevOps projects? That is very important. Okay. Let's discuss without orchestration how the process will work first. Okay. Guess simple process. My end sample application is there. The sample application is, for example, Node.js application is there. Okay, Node.js application is there. My end now. Developers are developed Node.js application. So this Node.js application front end and also back end also Node.js application. So developers already develop the code front end and back end. Okay. So in this case, full stack means what? Front end layer, back end layer, database. The project can take care of end to end. Okay. So one more layer is what? Database layer. I will give time to ask the queries. Just focus half an hour continuously. Very important. Okay. You will get it 100%, no doubt at all. Database layer. I'm going to take any database. RDS, MySQL I'm taking. Clear now? Okay. Now my developers are develop front-end code, back-end code, and also to store the customer's data, database also required. In this case, my applications are ready. Okay. Now you tell me here my users are there. Okay. My users are here now. Okay. So this application requirement given by one of the client. This application requirement given by one of the client. So as per the requirement, developers develop the code, front end, back end. Clear na? So developers are develop the code, front end, back end. Okay. So develop the front end, back end code. So now client is, okay, as per the client requirements, developers are develop the code. Okay. Now they want to release this application to public. For example, Flipkart, we everyone know Flipkart. Okay. So the Flipkart also the background first development phase is done, then release to public phase only, right? So now this is not yet released to public phase, still developing. Now they are decided, okay, application development is done, testing also done. You can release to public. Clear? Release to public means public can access this application. If public want to access this application, first you can run this application. Where we can run this application? Servers. Which servers? You can take cloud servers or on-premises servers, your wish. In this case, guys, I'm taking a big cloud network. Okay, I'm taking a big cloud network. So here I'm just explaining about front end only. Same process for back end also you can apply. Okay. So guys, my front end code is ready now. To run my front end code, so I'm creating one EC2 instance directly. Okay, EC2 instance directly in my subnet VPC inside. Okay, na. So now my EC2 is running. Okay, perfect. So application always run private EC2. If it is AWS EC2, EC2 only. Or Azure means VM. Google means Google Cloud Engine. Okay. So my private server is created. Okay. I have created a private server. Now from here to here, I have deployed my code into private server. Okay. So if you want to run this code inside the server, we should first install what? Dependencies. Right or not? Install dependencies. Okay. Okay, install dependencies. Okay. And next, install environment. If it is a Python means Python environment is required. If it is a Node.js means Node.js environment is required. So dependencies are there, environment also there. Now run a application inside the server. Clear no? Now how many servers are running here? Only one server. Clear now? Only one server. Now your uh, client is asking to the operation team, okay, operation team, how many servers you are creating now? Only one server. So this application, weekends, we have a traffic. We will get more traffic from the customers. In this case, your EC2 may not support, one server may not support, then you can go for 2, 3, 4. In this case, operation team, let's take one team. I'm taking a team here. Any one team, yeah. Okay, operation team is here. Now operation team need to take care as per the client requirement. Okay, so one server is not sufficient. So traffic may increase. In this case, what I can do? Your client is saying you can orchestrate this server, orchestrate this application to give high availability. Understand now? What client is saying? Traffic will be more. Traffic will be more weekends. Okay, in this case, you can orchestrate well weekends traffic. Understand? So what operation team will do? Okay, number of requests will increase means what they can do? Better to enable dynamic scaling. Some auto scaling concept they can enable, right or not? Whenever auto scaling concept enable, yeah, whenever auto scaling concept enable, what auto scaling will do? What auto scaling will do? Increases servers as per the demand. See, demand is increasing. Demand is increasing. So your client is saying demand is increasing. Orchestrate well. Okay. So my auto scaling group, I can increase the set point. So accordingly, here servers count will increase or not? Servers count will increase. Here also same application running, here also same application running. But now two servers inside same application is running. For example, application name is, you just understand Flipkart. Application name is Flipkart. Okay, application name is Flipkart. Now two servers are there. How to give access to multiple users, multiple end users? We need a load balancer. Very good. We need a load balancer. Who will orchestrate? Operation team only. Operation team, configure load balancer. Okay, Rabbani, can you please drop? I think this is very new to this concept. You may disturb completely. Okay. So this workshop is, once again I'm saying, whoever having cloud knowledge, whoever having DevOps knowledge. If it is very new to you, maybe very difficult to manage. You may disappoint completely. Okay. But at least, as I said again, if you're a fresher, try to understand what kind of concepts there in the cloud. Don't try to understand what is ECS, what is ECR. You don't know any experience, right? So very difficult. This is my suggestion. Otherwise, continue here to understand, okay, in AWS, there is a service auto scaling group. In AWS, there is a service EC2. Okay, in AWS, there is a load balancer. Like that, you can understand only. Right or not? Yeah. Load balancer. So for example, I'm from multi-cloud DevOps skill set. If I attend directly Java classes, first class is, I'm also definitely challenges are there or not. So I'm not, if I try to understand 100%, definitely completely I will drop from the Java training. Right or not? Not possible. It will take time to understand. So that's what workshops are, not for freshers. These are already completed training persons. They're to get a more calls. If they add these skill sets into their resumes, they will get more calls. Without taking training, these concepts are very difficult, guys, to understand. Okay, please understand. This is my request only. Okay. Now tell me, load balancer created by operation team or not? Auto scaling group created by operation team or not? So operation team orchestrating well to get high availability to end users. High availability to end users. So let me I'm trying to explain what is orchestration first. Then we can go for orchestration tool help here. Okay. Okay. So to give as per the client requirement, my client, what they requested, team, whenever traffic will increase, still you should support. Okay. Still you should support. For example, in the previous days, if you go for 10 years back, if you go to eServer, okay, always they can say server is busy. Server is busy. You can come and again go next day, right? They're compromising users, not resources, right? But now resources are not compromising. Where in the cloud environment, whatever resource required, you can take it. End user should satisfy only. That's what Flipkart always working or not. Amazon always working or not. These are e-commerce website, the background orchestrating well. The applications, we have a number of servers, we have a number of supporting from the orchestrating tools. Okay. This process, there is no orchestrating tool, for example. How to manage? Someone can manage, create a servers, someone can manage, configure auto scaling group to get more servers, someone can create a load balancer to give a access. Okay, clear what I'm trying to say now? Okay. Now, here operation team is orchestrator for this application. Understand or not? This operation team is not perform well. What will happen? Application will down, right or not? For example, auto scaling set point, if they give max is 2. My servers reach to max 2. Now, still load is there means 2 servers will crash. Third server will create, but your orchestrator is not giving set point 3. They are giving only 2. What will happen? Servers will crash. Clear now? Okay. Still they are doing their job very well. Still their doing job is very well. Now, one application, one load balancer, one auto scaling group launched. See, auto scaling group creating means what? The background dependencies are what? Launch template, AMI, everything. Who will take care? Operation team only. Clear or not? In this case, if my applications are 100, if my applications count is 100, what will happen, guys? My application count is 100, what will happen? This operation team take care of 100 application as an orchestrator. Means 100 applications should run always high available, should give always high available. Always high available means again they need to implement auto scaling group, load balancers. 100 applications means how many load balancers? 100. 100 applications means how many auto scaling groups? 100. Is it good? I mean, is it easy to manage? 100 applications, 100 load balancers, 100 auto scaling groups, 100 launch templates, 100 AMIs. Is it easy? If 97 load balancer is failed, to identify which load balancer is failed also, it will take 1 hour. Right or not? Which load balancer is failed out of 100 load balancers to verify it will take 1 hour or 2 hours also. And this load balancer is configured to which target group, which launch template, which AMS, it will take 1 more hour. Just to understand which load balancer is failed, it will take 4 to 5 hours time. Then when you can debug the issue, still offer is going on Flipkart, application is not running from the 6 hours. What will happen? Client lose the business or not? Today's offer, millions of people are waiting, application is not running because of no well orchestrated system is there. Clear or not what I'm trying to say? So now in this case, is there any services are there? I'm not going to orchestrate anything. Is there any service is there? I will hand over this application to that service. That service should take care of everything. Here operation team is 1, 2 applications they can handle, 3, 4 applications they can handle. My application count will increase. Hundreds and very difficult to orchestrate. Then I need help from any orchestration tool in the market. Okay. At present, the orchestration tools in the markets are Kubernetes, OpenShift. These are third-party tools. Okay. But we have a cloud native orchestration tool also. Cloud native orchestration tool means AWS ECS from the AWS cloud. Understand what I'm trying to say now? Okay. So what ECS is saying now? What ECS is saying that I'm a orchestration tool. Okay, you can hand over your code to me. I will orchestrate well, whatever you require. Clear? That is ECS concept is here. Okay, my N 100 applications are there. No problem. You can give it to me. I will hand over. I will take care. My N 1000 applications also there. Still no problem. 1000 applications you can hand over to me. I will take care. Okay. So in this case, what we can understand, application developed by developers, application deployed by DevOps engineer, application orchestrated by managed services ECS or Kubernetes. Understand what I'm trying to say? Perfect. In this case, in the market, as I said, we have a orchestration tools. So orchestration tools means what here? We have a Kubernetes. Okay, Kubernetes, open source platform. So anyone can use, developed by Google. Okay, developed by Google. Perfect. So now this orchestration tool is a open source platform, means any cloud also can use. Any cloud also can use means here AWS cloud is there, Azure cloud is there, GCP cloud is there. What they are doing, they are also offering this Azure and GCP. So what they're giving, they are also supporting this Kubernetes tools, third-party vendors tools. In that case, what you need to do, you can take and you can install. Okay, you can install in AWS cloud. So you can install Azure cloud, you can install GCP cloud. So as these are open source tools, right? You can install easily into any cloud. Okay. But what AWS cloud is saying, that Azure cloud is saying, that GCP cloud is saying, that instead of taking third party tools help, we are also providing same tools. The tool is ECS. Understand now? AWS native own tool, not a third party tool. This tool is only work inside AWS only. Clear now? For example, Terraform is a open source tool. You can install any cloud and work with Terraform. AWS Cloud Formation is a AWS native tool, only support for AWS cloud. Understand? So ECS is a AWS native tool. Clear now? Okay. So what are the benefits we will get if I use ECS instead of Kubernetes orchestration tool? Okay. So yeah, we have a orchestration tool. You know, right? What is orchestration? To give application high availability, to maintain application always running, to give a high availability to customer, we can orchestrate in terms of scaling, in terms of availability. The scaling and availability will take care by the load balancers, auto scaling, and everything configurations will take care by these tools. We can hand our application, rest everything taking care by this orchestration tools. Amazon EKS is a Kubernetes service tool. This is not owned by Amazon. Okay, still customer will take care 50% responsibilities. If you take a Amazon EKS as a orchestration tool, 50% responsibilities what they need to take care, we'll discuss later. But if you choose a Amazon ECS service, 100% they will take care. You no need anything. You just create what and all required. You can hand out to them. They will take care. Providers will take care. These services will come under AWS managed services. Very important now. Very popular also now in the market. Okay. Okay. Now, so guys, if you can see container service combination, your orchestration tool only support your application should be in the form of image only. This is very important point. Okay. Here, if you can see, you are directly deploying your application into server by configuring load balancer, by configuring auto scaling group without any orchestration tool. You are simply taking care. But application count increase means managing these many auto scaling group load balancer too difficult. That's what I'm taking help from orchestration tool. This is clarity. Next, But if you take a orchestration tool help na, the first condition is what? Your code should be converted into image format. Okay. So image format means what here? We are implementing containerization platform here. Containerization platform is nothing but what? By using any containerization tool, we can convert your code into image format. Then orchestration tool coming into the picture. Okay. So first code convert into containerization platform, then hand over to orchestration platform. Clear? Without containerization platform, your orchestration tool will not support. Clear? This is the main. Let me show you here in the new slide. So for example, my developers are developed a code front end, as I said, right? This is front end code. Okay, this is front end code. This is little difficult concept in the DevOps. So that understand, not easy to quickly, understand the process. This is, everything is dependent. Most difficult concept in the entire DevOps area. Orchestration plus containerization. These are the main core concepts. So definitely challenges are there. Okay, understand. Now my developer is, it will take time, just focus now. Okay, see, my developer is develop the code. Okay, now if you want to deploy the code, you can take EC2 instances. Same. So if you deploy the code onto the EC2 instances, servers, what will happen? Orchestration challenges are coming. Someone can orchestrate load balancer and auto scaling. Instead of that, what I'm taking here, I need orchestration help. Okay, I need orchestration help. Let's take, this is ECS or Kubernetes service. I'm taking ECS. So this application, if you want to hand over, this is code, okay? This code, if you want to hand over to ECS, first you should convert into image. Okay, this image conversion process is containerization platform will come into the picture. Containerization platform in the market is Docker. Okay, what Docker will do here? What Docker will do? Simply Docker will do here. Yeah, what Docker will do? Docker will take the source code and give a image. This is called Docker build process. How Docker will convert application into image format? Here you should write a Docker file. Understand? Here you should write a Docker file. The Docker file, you can add your application dependencies and all. Whenever you can build this Docker file, image will create. Which image it is? If it is a Flipkart code means this is Flipkart image. Understand? But here source code is as is. But here source code is image format. Understand the difference? Now you can hand over image to ECS. Now ECS will create containers in place of servers. Understand? The before case is what? Directly you are deploying application into servers. Who will orchestrate? Operation team. But if you need a well orchestrator, what you can do? Say, I'm taking a Docker help. Why Docker? My orchestrator can read only images only, not code and all. In this case, taking a Docker help, convert the source code into image format. Image is ready means you can hand over to ECS. Now ECS able to read your application, run a containers, not a servers. Clear now? The difference between server and container na guys, server in terms of size and all, server will consume more hardware to run a application. It will consume more dependencies. It is by default easy if you can create means the background 100 plus processes are running the background. Those process we are not using, but default dependencies for EC2 instance. I don't want default dependencies. My application is Node.js. I want only Node.js application dependencies only. In this case, I'm taking a Docker help. I'm taking a Docker help. Here, I will add only Node.js dependencies plus this code. Now, this image is nothing but what? Dependencies plus code. Clear now? This dependency is already added at the time of Docker file. Now this image contains what? Dependencies plus code. I need a runtime to run this process. The runtime may be server or container. But ECS will create container. Understand? ECS will create a container from the image. Clear now? So now let's discuss now. The very important part is coming into the picture now. Now ECS, whenever you can hand over this image to ECS, ECS can create a container from the image. This container contains what? Already source code. This container contains source code. Why? Container create from the image. Image inside source code plus dependencies also there, right? So ECS create a container. This container inside, this is container, container server, both are same. Container is a customized server. Understand? Just for a very customized server means what and all dependencies required I can add plus source code. Okay. So whenever you can customize the things, you can reduce the size of image. Whenever the image size is reduced, your container also running very less dependencies. So process also execute quickly compared to EC2. Okay. Okay. Let's see now. Your container is running, right? Your container also hardware is there. Your container also operating system is there. Now on top of that, application is here. Clear now? Application plus dependencies. So this OS, while creating a container, you can take this OS from the Docker Hub itself. So where my application is running. So now application plus OS plus hardware, right? Whenever you can run this container, the container will give a network like a server only. So users can access this container now. Okay. But container is running the background EC2 instance or FAR gateway. Okay, let's focus what is EC2 instance and FAR gateway. Okay, now guys, your container is running the background any one server only again. Now inside the server, how many containers are running? Only one container is running. So for example now, this container access you are giving to public. Okay, your container is accessing public now. So now your orchestration tool now, how it will work, see. Whenever this user's request is increasing, automatically this container is there, right? It will create one more container. Automatically it will create. You no need to do anything. Okay. And whenever multiple containers are there, right? You can create a one. You can inform to ECS, create a one service to give access. ECS will create a one service. The service is load balancer. You no need to do anything. Configurations and all just you can give, that will take care. So this load balancer will create now. This will access by users. Now two containers are not sufficient now. Your orchestration tool always watch the load and create two more containers. Like that it will create and it will delete. It will take care. But you need to inform to ECS. You need to inform to ECS the ECS configuration, the workload configurations, how much load you want, how much CPU required, how much RAM is required. You can inform to ECS. The rest everything ECS will take care. But this ECS job is, orchestrate your application to give access to users always, which means high availability. Clear now what is orchestration tool? Okay. So now this is ECS. ECS is completely taken care by 0 to 100%. responsibilities. It will take care. Orchestration tool. If you go for EKS process, EKS process also work like a ECS only. But the difference of EKS is EKS responsibilities will change. The reason EKS is a not fully managed service by AWS. Not fully managed by AWS services means they are going to be managed only 50 to 60%. Remaining, you will take care. Understand? But ECS fully managed by AWS. Then your responsibilities are very less. Understand? So if applications are small scale applications, go for ECS. Big scale applications, go for EKS. Clear now? Okay. So let's understand what is ECS. So ECS is a elastic container service. See, it's a scalable container orchestration platform owned by AWS. Clear now? It was designed to run, stop managing containers in a cluster. Means inside your ECS, the container's responsibilities start, stop, manage, scaling, everything taken care by ECS only. Okay. So the combination ECS will create a containers means containers, the background, we need EC2, but not 100 EC2s, only one EC2 is enough. Or two EC2s. One EC2 is in one AZ, one EC2 in one AZ. ECS cluster will deploy containers into one EC2 or other EC2. So ECS with combination of instance is there. ECS with combination of far gateway also there. So ECS with instance combination is what? You just hand over to ECS. These are my two servers. You can deploy containers in these EC2 instances. But EC2 with Fargate, you no need to define your workloads. Simply create a cluster. I need Far Gateway. You can deploy these images. Far Gateway will create the background of ECS. But ECS with EC2, you should define EC2s. You should create EC2s, hand over to ECS. But Far Gateway, nothing to do. ECS will take care. Fargate also, Fargate is a serverless service. That's what nothing to do to create by your end. But EC2 is a server service. You should create EC2 and hand out to ECS. Understand the differences here? Yes. Serverless service is nothing but what? Serverless service will take care by AWS only, not you. Then ECS with combination of Far Gateway. Far Gateway is what? Serverless service. ECS with serverless service combination is nothing to do by you. Everything take care by cloud providers. Again, ECS with EC2 combination also there. ECS with EC2 combination means here you can do 10% responsibilities. Take care of. The 10% responsibilities are you can hand over to EC2 instance. You are creating a containers, right? You can create containers into these two servers only. You can hand over like that only. But Far Gateway, target also taken care by ECS itself. Clear now? Yeah. See, in this variant, you don't need to worry about EC2 instances and servers anymore. Just choose the CPU memory combo you need. Your container will be deployed there only. But here, you can use ECS with EC2 instance. You can choose the EC2 instances, deployed EC2 instances that will hand over by ECS. Clear the differences? Yeah. What about Kubernetes? Kubernetes also same. But Kubernetes also we can do EKS with EC2, EKS with Far Gateway also. Kubernetes also will support Far Gateway. Guys, in the EKS class we discussed, right? Worker node responsibilities we should take care, right? In Kubernetes survey, Kubernetes tool, worker nodes responsibilities we should take care. Control plane responsibilities, they will take care, providers. So here also, I don't want to take worker load components also. Then take a Kubernetes combination of Far Gateway. So worker node also, they will take care. Then why EKS? I will go for ECS, right? But ECS limitations also there. It won't give thousands of applications hostings. So small scale applications and count is less means go for ECS. You need to deploy complex applications, number of applications required means you can go for EKS. Clear now? So both platforms will support combination of EC2 plus Far Gateway. If EC2 combination, if I take user, who will develop the application, who will manage the application, they will take 10 to 20% responsibilities in kind of patching, EC2 nodes and all. But I don't want to take that one also, means go for target nodes as a far gateway. Everything taken care by Kubernetes providers and cloud providers. Okay, we have a different options. See here, ECS with EC2. This is ECS cluster, this is EC2. This EC2s you have to hand over to ECS, then it will be orchestrated containers inside the EC2. If it is a far gateway, nothing to do. Create a cluster, select I need far gateway. Far gateway will create, application run inside the far gate, but that we don't know where far gateway also created. Simply we discuss AWS Lambda, right? AWS Lambda, far gateway, both are same. You can deploy your application inside the EC2 instance. But if you deploy your application inside the EC2 instance, instance patching, instance upgradations, instance OS change and everything you can take care, right or not? For example, if I want to install any CloudWatch agent, you can easily install an EC2 instance. But your application is running inside the Lambda, you are unable to install CloudWatch agent inside the Lambda function. Why? Lambda function is serverless. You are not taking care. Providers were taking care. So OS is not in your handout to connect a server to do any patchings. Clear? But as I said, Lambda far gateway both same. Then why far gateway here? Yes, difference is there. Lambda is a temporary runtime engine. It will run and stop after 15 minutes. Far gateway continuously run. Understand? If you choose far gateway service to run application, it will continuously run. Again, you may get a doubt. If it is a continuously run, I will take EC2 instance, right? Why far gateway? EC2 is a server. Far gateway serverless. Whatever benefits are there for the serverless, you will get it by choosing a far gateway. What are the benefits? Those are, if application is running in the server, server maintenance you will take care. If application is running on far gateway maintenance taken care by AWS provider. Your work will be reduced on the far gateway. Clear? Benefits you will get it. Costing also we apply accordingly. Okay, next. See, why I'm saying when we can choose ECS, when we can choose EKS. So this is the comparison. If you want to create a containers 150, ECS is not support. You can create till 120 containers only. Flipkart required 120 copies. Yes, ECS is okay. Flipkart required 200 containers. ECS is not support. Go for EKS. EKS will support 750 containers, means pods. Understand? 750 copies we can easily create by using EKS. But ECS, there are some limitations. 7 times more powerful EKS than ECS. Understand? Yeah. So guys, if you are able to understand this slide now guys, 60% DevOps you can understand easily. 60 to 70% DevOps you can easily understand. Only with this slide. Only with this slide. Your application is running on premises. Your application is running in EC2. Your application is running ECS on EC2. ECS on EC2 means orchestrated EC2. Here, without orchestrated EC2. Next, ECSR, EKS on EC2, some benefits. ECS with EKS far gateway, some benefits. AWS Lambda, some benefits. If you understand this line, 60 to 70% DevOps done, my point of view. Almost cover all the complex scenarios here. Clear what I'm trying to say? Yeah. So let's understand quickly 10 minutes I will explain. Try to understand, okay, what this slide is. I know there are challenges, but please understand, okay? So guys, my end, one application is there. Okay, my end, yeah, I'll explain, wait. EKS means Kubernetes only here. My end, one application is there. My client is saying my end application is there. Deploy. Answer is deploy this application. Where I can deploy? I have so many scenarios. Clear now? Where I can deploy. If I deploy in on-premises server, what will happen? You are the responsibility for everything for that server. Orchestration, maintenance, cleaning, electricity, ventilation, you are the responsibility. So this is very difficult job. Can you give permission to deploy on cloud? Yes, go ahead. If I go for to deploy application on EC2, what kind of benefits I will get, guys? Server maintenance, cloud providers will take care. Server dependencies, I mean ventilations, electricity, okay, security, whatever team is there, right? They will take care, they will give server access to you. You can take, you can deploy, you can access, right? But if you take a server access to deploy your application, still you need to take care of server OS or not. Which OS is required you are choosing or not. Which OS is required you are choosing or not while creating a server. Yes. Next, containerization is required. You need to install or not. Orchestration is required. You can take care or not. Scalability you can take care or not. Creating EC2 instance means everything they will not take care. They will take care what? The background, these two activities. Where the server is created, the background physical activities, cleaning, electricity, maintenance, they will take care. But running and everything you will take care. Running activities means what? Orchestration, scalability, runtime, containerization, integrations, everything you can take care, right? After creating of the server. So here are the responsibilities. So I'll inform to my client. You are saying deploy application on EC2, but now traffic is more, very difficult to orchestrate the servers. Servers count increase to 20, 30. So my end is very difficult to manage. Can I take orchestration help so that our work is very less? Okay, go ahead. Which orchestration? ECS is there in AWS. I will take, they will take care of orchestration. Okay. So what we can do? Simple. What we can do? Application is there na. We can take a Docker help. We can build a application in the form of image. We can hand our image to ECS. They will take care of orchestration. We no need to worry about scaling and everything. Okay, go ahead. Then you have taken a ECS. See now ECS, if you are taking na, ECS input is what? Image, right? ECS input image means you can take care of Docker containerization platform or not. First, write a Docker file, build a Docker, create an image, hand our image. In this case, ECS is not responsibility to create image. ECS is responsibility to, if you give a image, it will run. In this case, see, ECS on EC2 means only taking care of what? Yeah, containerization means ECS is a containerization tool actually. Okay. So if I take a ECS help here, they will take care of containerization. Orchestration also they will take care. You need to inform something. Okay, I need like this, I need like this, I need like this. Then they will follow. Clear? Same. EKS. EKS, if you can take, they are taking half of the orchestration. Half of the orchestration means Kubernetes, guys. By default, Kubernetes nodes will increase by default. Worker nodes will not increase by default. Nodes, if you can take a two, na, so many cases we have seen pod is pending state because of no resources are available in the node. But node is not increasing automatically, right? So that's what they will take care of pod level orchestration only, not node level. But Kubernetes will support node level orchestration also. For that, what you can do? You can take care of some responsibilities. In this case, orchestration, if you can see, off of the orchestration only. Only we will give pod level only. If required node level, you can configure something on top of that. Okay. Again, I'll call to my client. Still challenges are there. Then what we can do? ECS is saying that take a combination of our gateway. We will take care that whatever challenges you are facing to maintain servers and all, right, and that will also will take care. Client is saying that go ahead. Client is saying that go ahead. Now you are implementing EKS. Now EKS still scalability problems are there in EKS. Scalability problem, what I said no, node level scalability. They won't give. Only pod level scalability will give. I want to create a 20 nodes immediately when the pod load will increase. Kubernetes will not take care. You need to configure any one of the tool, Carpenter and all to take care of that. Again, I'll call to my client. Still challenges are there. Then is there any support is there? There is a Lambda function. Everything they will take care. I can deploy my application, directly it will run. Okay, go ahead. Finally, what will happen? Team size 50 to 1% only there in the team. Why? If you decrease the dependencies, what will happen? Here 50 members will work, right? Here 50 members not required. Here 40, here 30, here 20, here 10, here only 5 members will work in the team. Understand what I'm trying to say? You reduce the burden, right? You reduce the dependencies means you're increasing the technology, right or not? If you're increasing the technology, the number of headcount will decrease or not? Decrease. In this case, definitely challenges are in the market, right? I'm not getting calls. I'm not getting calls means when you will get a call, when you increase the technology. Understand? Still, if you think this level, how you will get a call? You can think this level. Increase your technology, understand the different scenarios, then you will get a understand, you will get a calls. Clear, no? Yeah. As a fresher, if you are taking this workshop, definitely challenges are there. 100% challenges are there. This is a good sign for you to start build your career in DevOps environment in this level. Okay. Yeah. Okay. So this is just introduction of what is ECS and all. Yeah. Thanks, Suresh. So now I will discuss these areas, the frequent questions, what they will ask in interviews later. First, we can do the practical. We'll go for practical. Okay. So again, dependency for the practical. Terraform knowledge is required to understand. Okay. Yeah. Yes, Pramod, you are right. Auto scaling can combination of ECS and EKS. We can take any combination. But if you can take a far gateway, you no need to worry that everything take care by team only. ECS team. Yeah. Okay, let's proceed to understand now. So this is my cloud repository, sorry, Git repository. So this is my GitHub URL. Okay, this is my GitHub URL. As I said, this is full stack development, right? This is network configuration stack repository, but my code is, so my code is here. Okay, my code is here. This is front end, this is back end. So if you want to take a ECSL, what you should do first, build a code into image format. In that case, I need a help from Docker to write a Docker file to build a image from the front end code. So front end image will come. Next, you can build a image from the back end code. Back end image will come. Later, you can push this image into any source code repository ECR. So this part already done my end. This is not workshop on containerization. This is orchestration. Okay. I'm not going to build. If you are interested, you can build. Docker file also here only inside. Okay. Just build. Image will come. Push image into ECR. Clear now? Perfect. Now, if you want to work with ECS, your end make it ready for image, right? My end from the front end code created a front end image that is ready. From the back end code, already I prepared back end image. Then where you are maintaining this image is there is a repository tool in the AWS ECR. ECS, ECR both are different. ECR is a elastic container repository where we can maintain the images. ECS is take the image from ECR, orchestrate and create a containers and give access to users. Clear the difference? Okay. Let's go to ECR. Yeah. So my end, front end, back end, images already ready. So that means from the front end code, I build Docker image is created. I push into front end. I push into back end. So these are images. Now images are ready. Let's go with ECS process, right? You can create a container also. If you create a container, you can orchestrate. But if you hand out ECS, they will create a container, they will orchestrate. So you just instruct to them in the file. I need 2 copies, 3 copies, 4 copies, whatever. You can instruct it to ECS. So ECS will take care. Clear? Okay. So let's go to ECS here. In Kubernetes, we already discussed the concept of pod, right? What is pod? Host the application. So I need 3 pods, means 3 replicas. So your application is running inside the 3 pods, means 3 replicas, right? In ECS, the terminology is task, not pod. Okay, in ECS, in Kubernetes, your application is running how many pods? You can say 3, 4, 5, right? But in ECS, your application is running how many tasks? Means pod. Clear? One task means one container is only running. 3 tasks, 3 containers only running. Understand? Like this ECS process is. Okay. Okay. So guys, here I'm able to see cluster and task definitions. Okay. Task definition means pod.yaml is there, right? Pod.yaml is for what? Pod definition. Here task definition means task. Task will create based on the definition. Okay. Let me show you the task definition. You will get a clarity now. So this is the repository. Yeah. See, ECS task. So now front-end code separately front-end code task, back-end code separately back-end code task. In the Kubernetes, front-end pod separately front-end YAML, back-end pod separately back-end YAML. Same here task, there YAML. Okay. Let's go to the front-end task service.yaml. Now you can see if your ECS create a 10 containers, for example, same application 10 copies. If you want to hand over these containers to user, load balancer required or not? But load balancer you are no need to create. ECS will take care if you take a Fargate help. But here ECS with ECT if you can take na, you can create a load balancer first. Why? In Kubernetes, if you want to give access for load balancer, what you need to take care? Service.yaml you have to create, right? Here we can create a service also same. In Kubernetes, pod.yaml, I mean deployment.yaml, service.yaml. In ECS, task.yaml plus service, I mean task definition plus service definition. Clear now? Yeah. Yeah, so this is the task definition. So I'm creating a task definition for what? This image. Okay, I'm creating a image. See, I'm creating image. I need 256 CPUs. I need 512 memory. Okay, where is the image? This is the image. Okay, so you are creating a task definition. Which task you need? This container run on EC2 or Fargate? You can choose any help. I'm taking Fargate help. So I no need to worry about EC2 instances now. So now this ECS will create a container on Fargate. Fargate is completely serverless service. You no need to do anything here. Clear? But to create a containers, you should give a image. This image already ready. Clear? This image calling from where? ECR. This image. So this is the path. Okay, this is the path I have given inside the task definition. Clear now? So what under CPU required, memory required, you can give here. So whenever I run this, task will create. Task means what? Container will create. But how to give access this container to external? Auto scaling, sorry, load balancer is required. If you create a load balancer service to give a container, before that you should create a target group, right? So I'm creating target group. And load balancer target group, inside I'm creating what? Listener. So this listener is forward to where? Forward this target group. Understand? So, I mean, load balancer with Terraform, I'm explaining only. You can create manual also, no problem. So I'm creating a load balancer, and load balancer target group is this one, front-end target group. So I'm forwarding into the front-end target group. Okay. So I'm giving say target group ARN is a this target group ARN. So means what? If the request is coming from the HTTP protocol, that will be redirecting into the ECS container target group. Okay. So then load balancer, if you can access means that is going to be access into the background containers. Okay. So load balancer, exactly correct Pratik. That will take care by, it will maintain the CPU memory only. Okay. Next, You just give only CPU memory. So I need this CPU, this memory. So it will allocate number of containers or one container or more CPU. That will take care orchestration. You don't need to worry. So now if you can see, my load balancer should create public subnets only, right? So I have given public subnets only here for the load balancer. But ECS task is creating in which subnet? Private subnets. Clear? In the manual process also, your application, if you deploy in the EC2 instance, application always run the private server. To give access to, you can create a public subnet to host into the load balancer. Same concept, but my application is not running directly EC2 instance here, running on containers. That containers taking care by ECS. Clear? Yeah. Same thing you can create for front end also. This is front end task, front end image, back end task, back end image. Okay. Now create a cluster. Cluster will create ECS cluster. How many definitions we are giving? 2 definitions. Cluster inside, total 2 tasks are running. One is front end, one is back end. Clear now? Perfect. So this is little complex one, guys. I mean, entire process is complex, but ECS is very easy. Whoever having Kubernetes knowledge. Okay. Okay. Now front end, back end is fine. What about database? RDS also required, right? First, you can initialize the database. Then you can run this ECS task, backend task. Clear, no? I think everyone knows, right? RDS, how to create and all. Okay. So let me explain here now. Okay. So let's go ahead. I'm going to take care of now. So CD, ECS workshop. I have created one directory here. So inside directory, I have cloned this repository. Okay. Okay. So inside, I have divided 3 directories. One is for network directory, one is for RDS directory, and second one, last one is ECS task. First, if any full stack project, if you are going to deploy now, first database should be initialized, then backend, then front end. Okay. So RDS creating means we need a network, right? So network also ready. This network contains public subnets, private subnets, internet gateway, NAT gateway, security groups, and everything. So this is real-time project, not like I'm not taking any public subnets directly deploying. So the application real-time, how it will work in the private network, how we can give the access through public network, everything is there in the network only, stack only. So I'll do one thing. Let's run this process. It will take 15 minutes of time. Meanwhile, I will explain the network also if required. Terraform init. Okay. Terraform plan. Okay. If you can see, my plan is going to be create 17 resources, means one VPC, 6 subnets, security groups, okay, NAT gateway attached to public subnet, routed to private subnet, internet gateway attached to public subnet, routed to public route table to public subnets. Network, the background network. Let's proceed. This project is enough as a main project in your resume. Okay. The reason, everything I covered here, Terraform tool, ECS tool, okay. So AWS network, very important network. Okay, let's go to explain this network now. How quickly? Yeah. So if you can see, first I'm creating what here? VPC, region I'm giving Mumbai, creating public subnet and creating a second public subnet. Why 2 public subnets? Load balancer service should access, right? For that. Next is what? Internet gateway. Next is route table. Next is edit routes for internet gateway. Next is subnet associations for internet gateway for public subnets. Next is route table for private. Next is creating a private subnet. Next, I'm creating elastic IP for what? NAT gateway. So creating NAT gateway and attaching this route table to private route table. and again creating a ECS route table and associate to private route table, same network, internet gateway, NAT gateway only. Next, creating a secret group for load balancer, and these rules I'm attaching to load balancer. Load balancer I'm not creating from here. Load balancer I'm creating from this task only. Backend containers will link to backend load balancer. Front-end containers will link to front-end load balancer. To create a load balancer, background network is required, right? I'm creating a network for RDS and everything. So here, this is not complex Terraform code. Somewhat level is okay. 60-70% level okay. I'm using dependency block, data source block, almost. But we can implement through module also, same concept. Okay. Okay, NAT gateway is creating. It will take 5 minutes of time. Okay. So meanwhile, yeah, network created. See how quickly it is created in 1 minute. I have created 17 resources. Understand, if you want to do this task manually, it will take 2 to 2.5 hours. Right or not? Again, NAT gateway, where is the NAT gateway? Where is the routings and all, right? The network is done. Next is what? We should prepare a database first. Okay, front end image is ready, back end image is ready. Front end image to front end container ECS will create. Back end image to back end container ECS will create. Front end back end will communicate, back end RDS will communicate. So that RDS I'm creating to write the data inside the database. Okay, let's create a RDS also. RDS also private, not public here. So RDS will give response to if the request is coming from internal only, same like a real time. So front end container, back end container only can communicate to RDS, not only front end container. Back end container only communicate to RDS, not all containers. And that too, no one can connect RDS from the external. My RDS is taking private subnet by creating a subnet group. So two to add, one is subnet group, one is RDS. Okay, Terraform. So don't choose any projects that are very silly projects in your resumes. Silly projects means created EC2. Say goodbye for the type of tasks now. Creating, I'm good in creation of EC2. I'm good in creation of S3 bucket. If that kind of resume, if anyone can see, directly eliminate that resume from the portal itself, Naukri. Technology changed completely. Now, if you learn DevOps in 2 months, learn cloud in 20 days, 30 days, no use. That kind of skill sets nowadays. If you prepare, consistency is required. 4 months, 4.5 months, 5 months, then only they will give 1 lakh per 1 month. Who will give? Yes, Dharma said correct. Who will give 1 lakh per month to create a S3 bucket? Right? Yeah. So whoever the new batch students, don't worry, you are going to be learn this much level. This is also not my main project. This is one of the sub project only. Understand? Yeah. Though you can consider main project, even I'm not compromising here also. We'll do little complex then, like that we'll go. If you practice like that only, so my training is not only to clear interview. So here, whoever plays in the companies, they are still surviving without single help from anyone. Not only to get a job, you can survive in your organization even though if you manage 4 to 5 years of experience. Like that level training is here. 5 months. Yes, Vidit is right. Vidit already existing employee. Surveying is very important. Getting job, the celebrations only 1 month only. You may get 1 month salary. Second month challenges will come. Everyone can understand you got a job, but you know the reality, your job already gone. That is very, very crucial condition. If anyone say, I will give you job, simply you can take and go, again you will come back immediately. Probation period is there. No, there is no value for probation period, okay? Employees permanent also, they will remove in 1 month, 2 months only. No weightage for probation period, ignore. That's what. If you want to prepare, yes, give your time for 5 months. Then leave it simply. After 5 months, yes, as I said, you can easily survive any organization. That level we will take care here. Still, if you are joining, still if you are joining, no voice is there. I'm shouting here. Okay. Still challenges are there, something are there. Means it's very difficult, guys. So my existing students, uh, guys, my voice is audible. Online team. Yeah. So Vivek, please, you can relog in one more time. So this is, I think, live also there, YouTube live. Okay. You can go through the recording, guys. It will take 3 days time to understand. No problem. Spend your time. This project will clear something in your interview. This project will help 50% in your interview. Terraform is covered, Kubernetes will cover, ECS will cover, Docker will cover. Most of the services, most of the tools, important tools. So database, as we know, it will take time, 10 minutes and all, right? Okay, now the important part I'm going to discuss now. Okay, let's jump. So in this project, I'm going to use Route 53 also. So where we can use, let's discuss now. Meanwhile, it will take 10 minutes of time. Okay. So now ECS images handover from ECR. Okay. Who will give images to ECR? Docker. Who will create image from the source code? Docker. This is what containerization tool. This is orchestration tool. Hmm? Roadmap we'll discuss. First complete the project. Hmm. So now, yeah, let's go to the full stack configurations. So guys, my front end code, back end code. That means here from the front end code, front end image is created, right? See, understand properly. This is my front end code. From where we can do the configurations. I'm explaining now. So this is back end code. Okay. Okay, this is not a correct. This is back end code. I will complete in 15 minutes only. Once database is created, just deploy only. No need to create load balancers, auto scaling groups and all. That will take care by everything. So front end will communicate to back end. Back end will communicate to database. Okay, these are the configurations in the three-tier architecture. Okay, so in my front end code, so this is not code. Code repository is here. My front end code. So if I go src pages, here I have given config.js. Okay, here front end will communicate to back end, right? In the three-tier architecture. So front end will communicate to back end. How front end will accessible from the users? Front end load balancer. And back end also load balancer. So now front end server will communicate to first back end load balancer. Back end load balancer is direct into back end code. I mean back end server. Back end server will communicate to database. Clear? Now database details will provide into where? Backend code. Now backend code details will provide into where? Front end code. Clear? Front end code into where? Config.js. Config.js. Inside config.js, I should give what? Backend load balancer. But at this time, I don't know my backend load balancer, right? When the backend load balancer will create? After create a ECS only load balancer will create. But how do I know? That's what I'm using Route 53 help. So I'm going to declare here veera.narni.co.in is my domain name. Okay. So, I mean, narni.co.in is my domain name. I'm using subdomain here. So here I'm giving veera.narni.co.in. So that means is what here? Here in my route 53, I will give here backend load balancer. Clear now? I will create a record for backend load balancer. So in this case, after create a task, simply I will go to route 53, Veera.Narni.co.in already calling in the front end to communicate a backend, right? I will create a alias record for backend load balancer by giving the same name. That means what? Front end code request will go to Veera.Narni.co.in route 53 record. Route 53 record will redirecting into backend load balance. Clear the concept is now? Perfect. Yeah. So front end to back end communication is front end code inside config.js. Inside I'm giving back end load balancer. But back end load balancer URL I don't know at this time. If I build a image now, the image inside also same config.js is there. How to change inside the image after creating a load balancer? Not possible. That's what I'm taking route 53 record. I'm declaring here on the same name. I will create a map to backend load balancer. That means if anyone hit Veera.Narni.co.in, request directly go to backend load balancer. That's what I'm giving here, front end to backend. Clear now? Perfect. No, front and back end data load balance are completely different. See, front end code will communicate to back end. User is not going to be access back end load balancer, right? User will access front end load balancer. Front end load balancer redirecting into front end code. Front end code is redirecting request into back end load balancer. Back end load balancer redirecting into back end server. In between, route 53 help I'm taking. Clear? At this time, I don't know my backend load balancer URL. Still, this code is not deployed. Even after deployed also, unable to change backend load balancer URL. Clear what I'm trying to say? Yeah. So now, if I deploy, what will happen? Front end image will come. If I deploy here, backend image will come. Front end image to front end container will create. Backend image to backend container will create. So this front end backend will communicate it to by using Veera.Narni.co.in. Backend to RDS. RDS details I'm going to provide inside the backend task.aml in ECS. Clear now? Yeah. Front end to backend solution is there right now. I've given. Now we can focus on backend to RDS, how the system will communicate. Okay. Let's wait. This is RDS. Okay. So front end container create from front end image. Front end image deployed from front end code. Okay. So this front end image deployed by as a front end container by using what? ECS. Okay. How many containers are required? We'll take care by ECS. This is backend. Clear now? Okay. Let's go and check database is created. Oh, still creating. Huh? Okay. So once RDS will complete now, 10 minutes we can complete this process. Simply we can create a task and open the route 53 and backend load balancer we can edit and complete it. Okay. So now tell me, anyone has any questions? We have a time for 10 minutes. How many days you prepared for cloud and DevOps? 5 months. Yeah, Jaimala, I will show you in the practical in the route 53, so you will get a clarity. Load balancer we are creating manually. We are hand over to ECS. Okay. Number of containers will take care by ECS. How many containers? Auto scaling is not required now. Understand? Auto scaling is not required. Okay. Let's go to Mumbai region. RDS is created in Mumbai region. Correct, correct. So this is mine. This is backing up. It will take just about to complete this process. I think in 15 minutes. How can freshers, how can I prepare means you can try. If you are facing any issues, you can take help from. So I'll do one thing is, okay, I'll do one thing. You can please join in this Telegram group. We are going to give support. This is only workshops project, sorry, workshop group. So you can join here. I'm sharing this link here. So the project repositories document also we will share how to execute this project, the steps and all. You can hit and you can join here in the Telegram group. Okay. Why user can access? Yeah, no access. Backend load balancer create internally only. Yes, correct. You are right. Yeah, this is about to complete in only 1 minute left. Okay. Task definition I will show. Just if it will complete now, I will take RDS endpoint and add into my task definition. Yeah, meanwhile, I will show you the task definition. Here I will show, you will get a better clarity. So backend should communicate to database, right? So backend task definition inside, I have added environments for database to connect. Clear now? The backend task definition inside, I'm adding database details. So from here, backend will communicate to RDS. So ECS service will create by using this load balancer backend. So first we should create a load balancer and hand over to ECS. This is, you can create a service by using this load balancer. Same thing front end also. Front end task definition. Use this service, this load balancer, front end load balancer. So number of containers that will take care by ECS. See, desired count I have given one, right? Always one container will run. You can increase 2, 3, 4, 5 also. Yeah, I'm creating through Terraform only. No manual process at all in the real time. So here also desired count is given 1. So task is 1 means one copy only, like a one pod. In your YAML file, if you give replica count equal to 1 means one pod only create, right? Same process. Yeah, database also created. My database is landed into the private subnet. So for that, I have created a subnet group. Let me show you. Calling private subnets only. So this subnet group I hand over to my RDS. So, but I'm calling data block for subnets. Subnets already created, right? While creating VPC network. So I'm calling the private subnet by using data block, and I'm creating a database instance RDS. Clear now? Okay. So now the very important thing is whenever I will access, okay, yeah, please you can join in the Telegram group. You can ask any query. I'm there only. After this workshop, if you stuck somewhere, you can take help from me. No problem. Okay. And the last challenge, guys, my database created a new database, right? I'm going to create a inside database, some existing records. Whenever I access a front end, existing records you can see first. Then you can add your records. In this case, database inside, you need to run some script to create a existing data. Okay, but the database, if you want to connect from external by using workbench and all, database should be public. My database is private here. In this case, from the same network only, you can create a database. In this case, what I'm going to do, in the same network, I'm going to create a one EC2 instance to connect a RDS to insert the records. Clear? This is also perfect. So let me create an instance in the Mumbai region. So I can say this is Bashan also. No problem. Okay. RDS is private instance. Bashan is public one. Yeah, you can use any key. No problem. So this is very important. I'm going to use which VPC? ECS VPC. Okay. And which subnet? Public or private? Bashan host always public, right? Yeah. So I'm going to use any security group. Let's launch a server. About to complete, guys, in 15 minutes only. This is the last one. Then we can run ECS task. So container will create from the image. Sudo su hyphen. Okay, my script is MySQL script is there inside this repository only. Let me clone to run a MySQL script, and before that, install git to clone the repository. Install git hyphen y. Okay, next I'm going to install MySQL. So MySQL we can install through MariaDB also for quickly. 105, or you can install directly MySQL also. Why MySQL client is required? If you want to connect database, you need to run MySQL command. MySQL -h-u-p. Clear or not? Okay. So now let's clone the repository first. Git clone. This is the code. HTTPS. ls cd ls. So my test.sql script is there in the backend, guys. Okay, test.sql. This script inside database, which database is required? How many existing records are required? Whenever I access a front end, I should see something, right? But this is empty database, so I'm inserting the records first. Next time onwards, I will access from front end. Now I'm not inserting the record from front end, directly I'm inserting. I can see some output now. From that, I can access front end. So I'm able to insert the records from the front end. Now I'm accessing directly now. So what is the command? MySQL -h endpoint. This is the one. Next is what? -u admin -p Veera Narni is the password, and less than test.sql. So successfully I ran test.sql script inside the RDS by connecting from here. So if you want to understand what is test.sql, I will show you here also. So this is the script. Create a first database, test database, insert database. Some records I'm inserting now. Whenever I access from the front end, these records I'm able to see. Later onwards, I can insert the records from the front end itself without connecting directly RDS. Okay, perfect. So now let's go to apply ECS also. In this case, ECS inside, we can do some modifications. Only for database modifications only. Details. So CD, ECS task. So now my end ECS task inside. No need to do anything front end, right? Back end inside. I should change endpoint. Okay. The reason my RDS inside I have given username is admin, password is this one. Endpoint we can know after creating RDS also, right? That's what I'm just changing this. The backend task here, the endpoint with my created RDS endpoint. Let's go and take now. This is the one. Clear now? Yeah. So this is also fine now. So username is admin, password is one, and everything is run now. Let's run a ECS task. So whenever I can create a ECS, so first cluster will be created. Okay. Then front end task, then back end task. These are dependencies, IAM role and all. Okay. Terraform. Let's run Terraform plan. So let's go to Terraform apply. Weekend effect. Huh? Okay. Oh, apply spelling is wrong. So definitely weekend effect only. Thanks, Naveen. Okay, let's go to the quickly Mumbai and open ECS. So cluster is creating now. No, cluster is not yet created. I think this is 01. Let's. Okay, cluster will create from the scratch. Cluster will create. Next, task definitions. How many task definitions? Front end and back end. So front end task creating from front end image, back end task creating from back end image. Okay, front end image, back end image communication through Route 53 record. Okay, that Route 53 record, I should create a load balancer alias for backend. So front end will communicate to backend through load balancer only. Service is creating now. So if everything is good, we'll complete in 10 minutes. Almost done. If cluster is creating, containers will create. We can access from the front end load balancer for front end task, back end load balancer from the back end task. So front end to back end communication, load balancer has to update in the route 53 record. Vera.narni.co.in communication is there, right? So front end image inside also Vera.narni.co.in is only there. The reason front end code image is created, right? Image also Vera.narni.co.in is there. But front end image communicate to back end image with the help of load balancer. At that time, I don't know load balancer, right? That's what I have given route 53 record. Now I'll go to route 53 record. I will map that Vera.narni.co.in into back end load balancer. I can say, guys, I mean, understanding this project also art. DevOps. Completing project later. Understanding also good. If you are able to understand, okay, you can understand something. Okay, this is DevOps. Okay, ECS is there, containers are there, Fargate is there, ECS is there. So you will get some idea, confidence. Same project we already discussed on Kubernetes, right? Same project already we discussed on Kubernetes, right? Same project we already discussed on manual process, right? Without containerization orchestration tool, directly deploying 84 EC2 instances. There we are using 8 servers. Now we are using 2 servers only. Simple. That is the difference. Servers count we are reducing monolithic to microservices. So whoever completed this project already on Kubernetes, whoever completed this project already on AWS, they can easily understand this easily complete. Okay, ECS creating. So yeah, let's go to the final one. So frequent questions. Okay, still it is creating. Let's jump onto these questions. So yeah, what is the difference between ECS and EKS and Far Gateway? Amazon ECS is owned service, is a managed Docker container orchestration. EKS is a third party Kubernetes based containerization. The difference is Far Gateway for ECS or EKS, you can use Far Gateway, the combination of EKS and ECS also. Which is better? This depends on you need. Amazon EKS deliver fully managed service for Kubernetes container, while Amazon ECS is ideal for Docker container. Okay. EKS is for what? Kubernetes pods. ECS is for Docker container, no pod concept. So, yeah, what is cheaper or more cost effective, ECS or EKS? With Amazon ECS, you pay only for the compute capacity to run your container. But EKS, it's not a free, $0.1 per hour per Kubernetes cluster. But ECS cluster is free, only you can pay resources only. Why use EC2 instead of Amazon for Gateway? If you want to significant control over a container runtime performance, go for Far Gateway. I mean, if you want to EC2, for example, 100 containers are running, your EC2 hardware is sharing by containers, right? 100 containers are occupied your EC2. Now EC2 is not enough to run 101 container. Again, you can create one more EC2. But if you can take a Far Gateway, you no need to worry about the resources. They will provide background continuously. You can create a number of containers. When should you use the Fargate instead of EC2 containers? EC2 for container. With Fargateway, you let AWS handle management tasks such as provisioning, configuring, scaling, everything's resources in time point of view, they will take care of Fargateway. So is Fargateway better than Kubernetes? Fargate is best suited for small to medium size applications only, as I said. Okay. But if you want to deploy a complex application, go for Kubernetes. Yeah, Fargate be used without EKS also. Okay, by combination of ECS. Why this error is coming? Let me, okay, let's go and check. Refresh. Actually, before cluster already there, right? Maybe the problem is, let's, this is active only. Okay, let's, but why cluster is not created? Okay, let me reapply again. We can destroy actually before I supposed to destroy and approve. The cluster I deleted manually, right? At the time, maybe it is taking. Yeah. Okay. Let's refresh the tasks also. Yeah, now refresh, deleted. Okay, let's run. You can apply. So maybe manually I have deleted before. So Terraform, so taking the same cluster ECS, I mean front and back end tasks. Yeah, no problem. So meanwhile, we can do one thing. So this cluster will create a already load balancer is created, right? The load balancer will communicate to this cluster. Meanwhile, you can go for load balancer. So backend load balance already created, right? Load balancers, okay, provisioning state now. Let's wait. Services are creating in the provisioning state. Let's wait. So it's creating now, about to complete in 1 minute. Refresh, still provisioning. Go to ECS, no here. Let's go to the ECS. So not here, Mumbai region, sorry. A cluster also created. Okay, let's go and check tasks. Active. Let's go to check the load balancers. Active. Okay, still it is creating. Meanwhile, what we can do, take the backend load balancer. What we need to do? Yeah, very good. Go to route 53. So hosted zone. Okay, so click on here. So Veera.narni.co.in is there, right? Edit records. I'm going to be give a backend alias load balancer. I will provide, yeah. So I will give which load balancer, backend or front end? Backend, right? Front end we can access, right? Backend load balancer, done. So this is also cool, done now. Let's go to front end load balancer now. Front end load balancer, you can create subdomain if required. If you don't want access to front end load balancer, you can go ahead for back end load balancer. So now you can access. Let's access HTTP protocol. Let's wait some time. Yeah, front end is accessing now. Let's wait for back end also. Can someone try your end in the group? I'm sharing in the chat. So 9 a.m. something I'm sharing here. Yeah, see, working fine. Just wait for some time only. Okay, so these two books records already I have added, right? See, now you can understand. Did I add two books from the front end? No. This information I added by using SQL script in RDS, right? In RDS script is ran right? Test.sql. There, these two books are added for just UI. Now, third, if I want to add anything, I can access from here only. See, this is, I'm going to add multi-cloud DevOps training. So you can give something description if you want to write, or you can give here something. Add. See, someone is deleting, don't delete a book. Okay. So delete API also there. Someone is deleting, please don't delete. Huh? Yeah, delete API also there in the backend code. So for example, why it is able to delete means a backend code is there, right? Index.js. Here post API, delete API, put API is there. So delete API, if I block, no one can delete. If I share my, URL. Clear now? Yeah. So now let's go and check now. Say I'm able to insert the record into my database. If you want to check, you are inside of here, right? You can log in MySQL -u. Sorry, same command. Okay. I'm inside of MySQL, right? You can check show databases. I created databases test. So, so my database is test. The script itself I have given the records are going to be inside this database only. Now show tables. Control C. Yeah. Why it is not exiting? It is interacting. Okay, show databases. Okay. Okay, this is yeah, yeah, okay, okay, no problem. This is inserting actually. Show databases. So test is there. Now you can use show tables. See, books tables are created, right? So select star from books table. You can understand the record. See, multi-cloud DevOps. Someone is added here. Who added? Huh? Thanks. $200, huh? Dharma added. So the front end, if you add a code, the records are inserted into database or not? Right or not? For example, if you go to Flipkart now, user is going to click on the mobiles. This is front end. Request is going to be directly database. User is able to check the mobiles information. Get method. Here user is able to delete. No, delete method is not enabled inside the code. So no one can delete, right? So the request, front end request will go to backend. Backend request will go to database. Okay. So database interaction from the backend, backend interaction from the front end. Clear? This is the process. It will work. So let's go to finally and check the ECS also, the task definition. See, backend, this is the backend task. So only one container is running. The reason task I have given only one, right? If you can give multiple, so multiple also run. In the task backend, yeah. If you go to task, the backend. So if you give here the backend task 2, 3, 4 something desired count, it will run 3 containers, 4 containers. Okay. Yeah. So I'm taking only just one container. If you give 10 containers will create if the load is more automatically. Orchestrating how many containers. Now auto scaling is not required here, but in the real, if your application is directly deploy on EC2, you need to be take care orchestration, auto scaling, scaling up. But here ECS will take care. If you give 10, for example, 10 tasks will create for backend ECS, backend application. That will take care. Clear now? Yeah. If you select EC2, your container is run on EC2. EC2 there is a limit. Some number of containers are increasing now. EC2 cannot not withstand to give a resources for ECS, so container. But for gateway, we no need to worry about the hardware for your containers. For gateway taken care by AWS provides continuously run environment. They will give. That is the difference. Even Kubernetes also, instead of creating worker node EC2 nodes, we can create worker for gateway nodes also. Okay. So this is the EKS and ECS. Whoever having EKS knowledge, ECS can easily understand. At the same time, vice versa also. Having ECS knowledge can easily understand EKS. Clear? So we will share the document to you guys. So you can go through the document. If you are having any doubts, please you can ping in the chat on here Telegram group. So we will help you accordingly. Okay? So are you clear? Whoever having DevOps knowledge, are you clear? Yeah, load balancer configurations already we are given in this ECS, right? Let me show you. So load balancer configurations, see if you can see here inside, we're giving target group, network mapping, whatever subnet you are taking, everything is same like that. Clear na guys? Okay, thank you so much. Have a nice day. Happy weekend. Take rest Sunday. Start from Monday. Okay? Yeah. Any queries from online team? Any queries from online team? Yeah, perfect. Bye.